Alright, we're going to find a rule from a table, guys. So first thing, let's go back and look at our rule. Y equals mx plus c. The m value there stands for the gradient, doesn't it? That's like the slope of the line. In a table, that would be like our first difference as well. Alright, this plus c off the end, well, that's our y-intercept. That's where the line cuts the y-axis. You know, that axis is the vertical one. Alright, to find the y-intercept in a table, all we've got to do is go to when x equals 0, and the y value that's with that is the y-intercept. Mate, that's pretty easy, eh? Oh, hang on, before we go on, we've got to know that y equals mx plus c is the same as y equals c plus mx. Let's not get confused here. That m is still the gradient, c is still the y-intercept, remembering the m is the first difference, and the y-intercept is when x equals 0. Alright, let's look at a couple examples to sort of get an understanding of this, eh? Let's write out some steps. Step 1. Let's check our x values first. Make sure they're increasing by 1 each time. It makes life a little bit easier, eh? There we go. Yeah, that's all going up by 1, so that's good. Now what we want to do is we want to check the difference between the y values. So the easiest way to do this is, first of all, to check that the y values are either increasing or decreasing. Hey, they're increasing, which means our difference is going to be positive. And look, they all have a positive value of 2. Now that's pretty easy. Now that means it's increasing by a constant rate. And that constant rate indicates the gradient. It also indicates that it's linear. Therefore, that m value is equal to 2. So that there is our gradient. Alright, well that makes things pretty easy, eh? We got our equation y equals mx plus c. If m equals 2, well, we just swap those. Get rid of that m and put a 2 there. Y equals 2x plus c. All we've got to do now is find our c value. Alright, remember our c value was our y-intercept. Now this is when x equals 0. So we find our y value when x equals 0. Well, there's x equals 0. Go along in your table, and our y value is 1. Now you know what that means. That means your c value is also equal to 1. Alright, all we've got to do now is take that 1 and put it into our equation. So replace that c with a 1. Hey, pretty easy, eh? Y equals 2x plus 1. So remember, that's our gradient too. We got it from our first difference. And our c value, or y-intercept, we got that from our table when x equals 0. Alright, let's look at another example, eh? Check the x values. Sweet, they're going up by 1. Check the y values. The first difference goes up by 1. Goes up by 1. Goes up, yeah. Man, it's constant. That means our m value is going to equal 1 now. Our c value, well, let's find when x equals 0. Go along. There it is. Circle it. What's our corresponding y value? It's 4. Sweet. Now let's write our equation. Y equals 1x plus 4. Mate, that's pretty easy, eh? We don't need to have that 1 there, but, you know, it's okay. We can still have it. So y equals x plus 4. Now, we probably should check to make sure it's correct, eh? And the way we check this is by substituting a point in. And what we're doing is we're checking to see if the left-hand side equals the right-hand side. So I'm going to choose an easy point. Let's choose, well, I left that negative off. Let's choose 1 and 5. Mate, they're both positive. Alright, let's write our equation out. Put the points down, so y equals x plus 4. 1 and 5. So there's my x value there, there's my y value. Let's put it in. So we're going to have 5 on the left-hand side is equal to 1 plus 4. And I think my maths is pretty good. I think 1 plus 4 does equal 5. Therefore it works. Awesome. Alright, man. A few more examples, eh? Oh, hang on. Got to check that the x values are going up by 1 each time. Remember our steps. Alright, this is going down by 2. You can see it goes down, goes down. We keep going, goes down. It's all the same, which means it's going to be linear. And our gradient is negative 2. Our c value is x equals 0. There you go. It's going to be at 8. And all we've got to do is put it into our equation. Y equals negative 2x plus 8. Mate, that's sweet, eh? Alright, goes up by 1 each time. Let's look at this example. Alright, just because you've got halves, hey, that's gone down by a half. Let's keep checking. Goes down by a half. That goes down by a half. Down by a half. Down by a half. Down by a half. That means it's constant, which means our m value is negative a half because it's going down by a half. Well, let's find our c value. It's x equals 0. It's 1. Now, that's pretty sweet. So we're going to have y equals negative a half x plus 1. I don't know, man, this is starting to get easy, eh? Alright, so let's look at example 5. Check the x values, they all go up by 1. So now let's look at our first difference. That goes up by 4 there. That goes up by another 4. Well, that only goes up by 2. That's not good. So let's check the x values again, make sure we got it right. Yeah, they all go up by 1. So let's just finish it off anyway. Goes up by 4, 4 and 4. Well, you know, for it to be linear, that has all got to be the same. So we can say that this is not going to be linear. So we can't find a linear equation. Alright, sweet. Let's just move on to the next one, eh? Check the x values. Cool. They all go up by 1. First difference, well, that goes up by 4. 3 to 7 is 4. 7 11 is 4. Well, next one's going to be 4. Yeah, they all seem to be going up by 4, which is sweet. Tells us that our gradient is equal to 4. And let's find our y-intercept. Oh, we've got a bit of an issue here. We don't have an x value that equals 0. Alright, but that doesn't mean we can leave it. Let's just put a 2 there. And then go back 1, go back to 0. If we can find the corresponding value for that 0, it'd be sweet. Well, if it's going up by 4, let's go back by 4. Alright, that takes us back to negative 5. Go back another 4. That's going to take us back to negative 9. And then go back another 4. Well, that's negative 13. Sweet. There's our C value. Hey, that wasn't too hard, eh? So that means our equation would be y equals 4x take 13. Okay, nice and simple. You know. Hey, but you know what? Let's look at another method that we could use here as well, eh? It's called substitution. So if we could substitute a point in and then solve or find our C value, well, that would be able to work it out as well. So let's choose a point to substitute in our equation. Remember, our gradient there is equal to 4, so our equation can be written as y equals, there it is, 4x plus c. Alright, we want to choose a point. I don't know, let's choose a really easy point, eh? So 4 and 3, they're both positive, both low numbers. Our 4 there, that's our x value. The 3 is our y value. And let's substitute correctly in for y. There you go, we're going to put a 3 there. We put our equal signs and we go 4 times x. Now x is 4, so 4 4s are 16 plus c. Now we want to solve for c, so we want to get c by itself. So we need to get rid of that 16 by subtracting 16. And what we do to one side, we do to the other. So 3 takes 16. I know that's pretty hard, but it's negative 13. So there we go. C is equal to negative 13. Another way is, you know, bring that positive 16 over, we get negative 16. So here's our equation, y equals 4x take 13. Alright, so not too hard, eh? Maybe we'll look at doing a quick summary, eh? So remember, what was the first thing we had to do? We had to go off and find that value of the gradient. That was our first difference. There we go. We then had to substitute a point in to find C. We chose an easy point, 4 and 3. Alright, we substituted in for the x and the y value. And then we tried to find the value for C by solving, making C the subject, or getting rid of what's with C. And that got us negative 13, which got us our point. Man, that's sweet. So I suppose you fellas now should be able to find any linear equation from a table. Hope you enjoyed the presentation, eh?